Welcome to another lecture on OSI Reference Model. Today we'll see about the unit of transfer, addressing, protocols and functions of each layer of OSI Reference Model. OSI Reference Model has got 7 different layers. We have seen every layer will communicate with its peer layer with the help of peer-to-peer protocol. Similarly, every layer will communicate with the layer beneath it with the help of interface. For example, application layer will communicate with the presentation layer with the help of layer 7 to 6 interface. We saw that physical, data link and network layers are generally called as the lower layers and the other layers are called as upper layers. The significance of the lower layers are that they are the direct communication among the different links. That is, when a source is sending a packet to destination, there will be number of intermediate routers. So these lower layers will be involved in these communications between every link. That is, between a source to a router to a router, or a router to a destination. We have seen various unit of transfers in each layer. Let's have a recap. In physical layer, the unit of transfer is bits. In data link layer, the unit of transfer is frame. In network layer, the unit of transfer is packet, and from transport layer, it is called as the respective layer protocol data unit. In transport layer, we can also call it as a segment or TPDU, transport layer protocol data unit. Similarly, in application layer, we can call it as a message or application layer protocol data unit. Let's see about addressing. The address used in the lower layers, namely physical and data link layer, is called as MAC address. A MAC address is a 48-bit address which is usually denoted in hexa form. And the address used in network layer is called as the IP address. IPv4 address is 32-bit and IPv6 address is 128-bit. There are different protocols which operate in each layer according to its function. For example, physical layer can have its own protocol for communication and encoding. Similarly, data link layer can have its own protocols. For example, it can be IEEE 802.11 protocol for Wi-Fi communication, otherwise IEEE 802.15 for Bluetooth communication. In network layer, we can have protocols such as IP, ICMP, IGMP and so on. In transport layer, we can have protocols such as TCP or UDP. In application layer, we can have any protocol such as HTTP, SMTP, SNMP, FTP or any other protocol as per the application that runs it. Now, we see about the detailed functions of each layer. As we know, the function of physical layer is to carry a bit through the transmission medium. The transmission medium could be either a guided medium such as a wired cable or fiber optic, or it could be an unguided medium such as a wireless communication. In physical layer, the important functions are bit representation and encoding. For example, the bit 1 could be encoded as -5 to +5 voltage, or it could be represented as -5 to 0 and 0 to 5, depends upon the encoding technique. We have the transmission rate which should be defined, which is the number of bits sent per second. We have seen the various physical characteristics of transmission medium. Each transmission medium has its own characteristic. And synchronizing. What is synchronizing? In case of sending certain bits, we should synchronize the clock so that when we send 0 or 1 bit, it can be received at the same time by the other side. And one line configuration. The physical layer is concerned with connection of devices to the media. It could be a direct point-to-point connection or a multi-point connection. There could be different transmission modes such as simplex, which is one-way communication, half duplex, which is two-way communication, but at a time the communication can happen only in one direction, or it could be a full duplex communication which can happen in both directions at the same time. We have also seen what is physical topology, how the devices are connected with each other. It could be either by bus, ring, stop, mesh, or any hybrid topology, which could be a combination of different topology. These are the functions of data link layer. The first function of data link layer is framing. Framing is grouping up of raw bits into frames. When the physical layer gives the bits to the data link layer, it will combine the group of raw bits to form a frame. Then physical addressing, that is assigning a MAC address. Flow control. Flow control is synchronizing a fast sender with a slow receiver, meaning that some sender could act very fast and because of its own capability that it will send packets in a very fast rate. But what about the receiver? The receiver capability will be different. So in case of data link layer, we need to synchronize a fast sender and a slow receiver so that the frames are sent in a synchronized manner. You can see this is the MAC address in hex notation. You can see this is the network interface card inside which the MAC address. Other functions of data link layer are error control and access control. Error control is dealing with lost, damage and duplicate frames. What is a damaged frame? A damaged frame is a frame in which zeros are converted to ones and ones are converted to zeros. The receiver does some computation to check if the data matches with the data that has been sent by the sender. If not, it finds that the frame has been damaged. Dealing with lost frames. Whenever a sender sends some data, it also starts a timer and waits until the timer expires for the acknowledgement from the receiver. If the sender doesn't get an acknowledgement, then it assumes that the data has been lost and then resends the data. Next is the duplicate frame. Suppose the sender waits until the timer expires and resends the data. But due to some reason, the receiver had already received the data but has sent the acknowledgement to, the acknowledgement has been missed during transmission or the acknowledgement arrives late in the sender side. Meanwhile, the sender has already sent the data to the recipient. Now, this frame is the duplicate frame. How it is identified? Every frame has a sequence number and the receiver waits for a frame with a particular sequence number. If that sequence number doesn't match, then that particular frame is discarded. Next is access control. What is access control? It is the sharing of the common bandwidth or common transmission medium with all stations. Access control is allocating access to the shared medium to different stations that compete for that particular medium. Now, coming back, the functions of data link layer, as we have seen, it is framing, MAC address, error control, access control, and flow control. This is data link layer function. It is a lower layer. We'll see the functions of network layer. The primary function of network layer is routing. What is routing? Routing is a process of forwarding an incoming packet to any one of the outgoing link. The router performs the routing. The second function of network layer is logical addressing or allocating an IP address to each of the system. The IP address uniquely identifies a host in the entire internet network. The network layer is responsible for delivery of individual packets. If it receives one packet, it will see how to deliver it through the correct link to the destination. You can see here there are physical, data link and network layers. All these three layers are dealing with delivery between hop to hop, from system A to router B to C and C to D. In case B is a router, the function of router is to forward an incoming packet to any one of the outgoing links. Suppose A sends a packet to B. Now B refers to its routing table. It sees whether the destination address is D. If so, it will know that the next outgoing link is the link to C. Therefore, it will be forwarded to C. And the router C will again see its routing table and it will know that the destination D is directly connected to it and hence it will forward the packet to the destination D. Okay. Here I would like to say what is an IP address. IP address is an address allocated to an interface. Normally we do think IP address is an address of a host. Yes, every host does have an IP address. Yes, if a host is connected to more than one interface, then that host is called as a multi-home host, in which case it has more than one IP address. For example, you can see here the router B. Yes, the router B, it has got three interfaces. One interface is for the router C. Another interface is for router E. And another interface is for system A. Yes. So this router B has got three different IP address for three different interface. In case we are connected, normally we are connected only to one network, therefore we have only one IP address. We shall see the function of transport layer. The main function of the transport layers are segmentation and reassembly. What is a segment? It is the smaller message. The message which is received from the application layer is divided into smaller segments. This process is called as segmentation in case of the sender side, and receiver side it is the reassembling of segments together. Next function is error control. We have already seen what is error control and flow control in data link layer. The functionality is same. Error control is dealing with loss, damage and duplicate frames. Flow control is dealing with the flow between the fast sender and slow receiver. Then why we need to have two different error control and flow control mechanism, one in data link layer and another in transport layer. Yes. So I said the lower layers are physical layer, data link layer and network layer. This transport layer is called as first end-to-end layer, meaning words, it is the first layer which connects the sender and receiver. If you could recollect the previous diagram, until the network layer, it deals between links. Yes. So naturally the function of error control and flow control in data link layer is to deal with links. And whereas this transport layer deals with error control and flow control between the sender and receiver. That's the difference between the function error control and flow control in data link layer and transport layer. I repeat, data link layer error control and flow control deals in the link, and transport layer deals between the end systems, the sender and receiver. The next thing is transport layer deals with process to process delivery. We have seen that in transport layer there are two address combined together, IP address and port number. Port number represents the number for the application or the process which runs in a system. So it's the duty of the transport layer to identify the specific application or the process to which a packet must be delivered. That's about the transport layer. And the next, that's called a service point addressing. You define the service point to which the packet must be delivered. The service point is IP address comma port number. And we know transport layer has got two different protocol. One is TCP and another is UDP. The transmission control protocol and user data rate protocol. What is the difference between these two? In case of TCP, it is connection oriented, meaning which before the transmission, a connection must be established. After a connection is established, all packets will take the same path. TCP is reliable. Why it is reliable? Because it receives an acknowledgement. Whereas UDP, it is connectionless delivery. It will not establish any connection. Yes. As and when it receives a packet, it transmits through any one of the outgoing link. There is no acknowledgement in case of UDP. In connection oriented service, there are three phases, namely connection establishment, data transfer, and then connection termination. We have seen there are unique port numbers defined for each process. The total bits allocated for port number is 16 bits. So totally there can be 2 power 16 different port numbers. Some of the port numbers are well defined ports, and there are some standard ports, and there are some user defined ports. So these are the well defined ports. For example, the port number for FTP is 20, for SMTP it is 25, for HTTP it is 443, and so on. You can see here the transport layer receives from the session layer or application layer the message and divides it into smaller segments, adds the header to each of the segment, and then gives to the network layer. Similarly, in the recipient side, from network layer, the segments are gathered, headers are removed, combined together, and is given to the application layer. You can see in a single system there are number of processes running. So the job of the network layer is to deliver to the host, and the job of the transport layer is to deliver to the correct process or application. Coming to session layer, in case of OSI layer, the application layer, presentation layer, and session layer are three different layers. Whereas in case of TCP IP, all these three layers are combined together. Let's see the function of session layer. The first function is dialog control. It allows the dialogue between two different systems. It's like after you establish a telephone call, both of you start the dialogue. The same is the responsibility of the session layer. Another function is synchronization. What is synchronization here is, synchronization is always synchronization between two different ends. Yes, here it adds a checkpoint to the stream of data. Suppose if we are going to send 1 KB of data, this session layer will add some major synchronization point and minor synchronization point. Suppose after establishing a connection, your message is getting transferred and due to some problem the message is not received, then from where to restart? Yes, you cannot restart transmitting from the beginning. Instead, we'll go back to the major synchronization point and then start retransmitting. Then this is the function of the session layer. First one is dialog control. Next one is synchronization. You can see the synchronization points are inserted by the session layer. Next is the presentation layer. Again, the responsibility of the presentation layer is to deal with the difference in formatting among your display unit. The sender will have a display unit or a monitor with different capability and the receiver will have a monitor of different capability. So it is the duty of this presentation layer to do that translation to a common format. This syntax will refer the information such as character codes. So it also does some character conversion. If suppose one system uses ASCII and another uses EBCDIC, it is the duty of the presentation layer to convert across these formats. The other function of the presentation layer is compression. You know what is compression? When you send large chunk of data, it takes more bandwidth. Therefore, what you do some compression at the sender side and then you send it to the receiver and the receiver end you will do the decompression process. This compression and decompression is also a function of this presentation. The next function is encryption. We know what is the use of encryption. We don't want our data to be seen by all intermediate routers and systems which are forwarding our data. So what we do in the sender side, we encrypt the data, send across the network and finally the receiver will decrypt the data. Again, it is the function of the presentation layer. So it does encryption in sender side and decryption in the receiver side. The function of application layer. Any client we run in our system, it runs an application layer protocol. If we want to download a file, we use FTP protocol. If we want to browse, we use HTTP protocol. For sending mail, we use SMTP protocol. For diagnosing, we use SNMP protocol. There are umpteen number of protocols used in application layer. The final objective of any network communication is to communicate between the application layer of the sender and the application layer of the receiver. You can see here the user communicates with the receiver with the help of application layer. The message is to be transmitted to the receiver. As we have seen, every layer will attach a header and then transmit the message to the layer which is beneath it. To summarize the functions of each layer of OSI model, the major function of physical layer is to transmit the bits over transmission medium and do encoding and transmission. Data link layer, it is framing, error control, flow control, media access control. Network layer, it is IP address, routing of the datagrams or packets. Transport layer, we do provide connection oriented service, connectionless service. The main function of transport layer is to connect the end systems, whereas the lower layer connection is across the link. The session layer to establish the session or the dialogue and synchronization. Presentation to present in a presentable format in the display unit and also encryption and compression. Application, it allows the access to network resources with the help of various application layer protocol. So we have learned the functions of each layer of OSI reference model. The TCP/IP reference model also, the functionality is same. The only difference is that the layers are grouped together. For example, application, presentation, session are grouped as the application layer. We do have the other layers as such. Thank you. So we have seen what are internetworks, what are layering, what is protocol, what is peer, what is the unit of transfer, what is the address used in each layer, and what are the functions of each layer.